Section 18, question 1. AC is a tangent to the circle with centre O with a point of contact B. DE is a diameter of the circle and F is a point that lies on the circumference of the circle. Angle ABD is 77 degrees and angle DEF is 64 degrees. Calculate the size of the angle BDF. So BDF is this angle here, BDF. So I'll just mark that in. So really, to get the size of this angle, I basically just need to find the size of that bit and that bit. So I'm going to concentrate on this particular bit here. Now, a couple of things to spot in the question. First of all, this line is a tangent. Now, a tangent exists at a 90-degree angle to the radius, so I know that this angle in here will be 90 degrees. Now, since the biggest part of it is made up by 77 degrees, 77 off a 90 tells me that that angle in there is 13 degrees. And I would show a wee bit of working for that at the side. Now, what you can also spot is that this line is a radius, and so is that line a radius, which means the triangle DOB, that is definitely an isosceles triangle. So that's a radius, and that's a radius. Now, for isosceles triangles, we know that there's two equal sides and two equal angles. So if this small angle in here is 13 degrees, that small angle in there must also be 13 degrees. Now I'm going to try and find out this angle. Now, next thing that I can see is I've got a right angle triangle here, because that's the triangle that will be inside a semicircle. Every triangle inside the semicircle is right angled. So I know for definite that that's a right angle 90 degrees. I know that this angle is 64, so I can find the third angle by adding up 64 and 90 and taking that away from 180. So that'll be 154 degrees. It's then 154 off of 180, and that'll be 26 degrees. So the angle BDF is given by those two angles totaled up. So that's what I'm going to do. Add on 13 and 26, and that will give me 39 degrees, and that's the final answer to the question.